Another method of solving a system of linear equations, or any system of equations for that matter, is by elimination. And the idea behind elimination is to cross off one or both of the variables. And to do that, we need to have the same number in front of one of the variables. Now you notice that everything is lined up, and we have this already. A -3 is in front of the x, and that is just really fortunate that that happens. Because if the same number is already in front of the variables, then we can skip a basic starting step and just go ahead and subtract the two equations from each other. So when we're subtracting, we would do top minus bottom, so we say -3x minus a -3x is 0, and it is eliminated. And that's why it's called elimination, because we're trying to cross off one variable. And we say a -1y minus a 2y would be a -3y. Be very careful with your signs during your subtraction. Don't forget to look at the negative in front of the 1 and a negative in front. And remember, we are doing subtraction, so you do have to remember that. 21 minus 30 would then be 7, or 9, sorry, -9. So we have this simple equation of -3y is equal to a -9. And that'll get me, of course, y is equal to a +3. Now that is one part of my answer, and the other parts can come from just plugging that 3 back into the original equation. Remember that we found y in this case, so we need to plug it into y. It does not matter which original equation you plugged into. I chose the top. 3x minus 1 times y is, well, just simply 3, equals 21. We can solve that by adding 3 to both sides and get 24 is equal to a -3x. Therefore, x is equal to a -8. Now, a lot of things can happen at this point where people are just not paying attention. We want to make sure that when we write our solution, it is the x value first and then the y value, not the order of the numbers that we found. A lot of people switch that up, so be careful with that. Now that is a very simple example. This one has a similar situation where the y's in this case are already the same. So you want to make sure that you're looking for the x's and the y's, and because you could save yourself a lot of work by just simply subtracting. You'll solve for x first on this one. I'm not going to do it because we just did one that's very similar. We're going to go to number 6 here, which looks a lot very similar to each other, but they're different because the numbers are x's and y's. So now we look at either this number or this number. We're going to try to make them the same. And the simplest way I would say to do that would be to simply switch the numbers in front of the x and distribute to both equations. So instead of having a -2 on the bottom, I'm going to put a -2 in front of the entire equation on the top. And since there was a 5 on the top, I'm going to put a 5 in front of the entire equation on the bottom. And then I'm going to distribute. So we distribute that to everything and we'll get a new equation. The new equation we're going to get is a -10x minus 4y is equal to 29 times 2 is 58. So that would be a +58. Then we would do the same thing on the bottom. We'd distribute the 5 to all of that equation. We'd have a -10x. Then we'd have a +25y. And then we'd have a +145 right there. Now this tends to get me some big numbers whenever I'm doing the calculations, but big numbers are not a problem. So what we want to do is we want to subtract it. Now that our numbers in front of our x's are the same, we're going to subtract the two equations from each other. So -10 minus a -10 is pretty obvious. That's going to cancel out, and we have effectively eliminated the x's. Then we have a -4y minus the 25y is a -29y is equal to, and then we get to the 58 minus the 145, and that is a -87. Now this is a simple equation to solve. Even if it has big numbers, we can divide by -29 on both sides, and that'll cancel. Y is equal to a +3. Now we have just found y. We need to find x, and to do that we want to plug it back into either of the original equations. It does not matter. I tend to choose the top just because I will usually like that one better, but it doesn't really matter which equation you plug it into. So we have 5x plus 2 times what y is, which is 3, is equal to a -29. And this is a simple equation to solve. 5x plus 2 times 3 is 6, which equals -29. We'd subtract 6 from both sides. 5x is equal to a -35, and therefore x is equal to a -7. Be careful with the order. Your final answer would be a negative 7, comma 3. That is the place where these two lines would intersect. Sometimes we'd have to do it to both, but sometimes we can save ourselves a little bit of effort by just simply multiplying one of the equations by a number. If you look at number 9, for instance, number 9 has, the 18 and the 9, or it even has the 4 and the 2. And we don't have to switch the numbers in front of the x's or switch the numbers in front of the y's. We can simply multiply the bottom equation by just 2. That would be a nice logical number to do, because when I do that, 2 times 9 is the negative 18, and 2 times the negative 2 is the negative 4, and that is going to really help me a lot in this. So we're going to have two equations. The first one stays the same. I like to write it again just because it helps me to do the subtraction later. But the second equation is going to be negative 18x minus 4y is equal to 6. Now when I do the subtraction, you should notice something. Negative 18 minus negative 18 will cancel. Negative 4 minus the negative 4 will cancel, leaving us 0 is equal to negative 16 minus 6. It really doesn't matter what this is negative 22. 0 equals negative 22. Well, that's interesting because I have no variables. I don't have any y's, I don't have any x's, I just have a number equals a number, which is not a true statement. So this is an example of no solution. Not all the time, whenever you only multiply one equation by a number, are you going to get no solution. It just happens to be on this case because both of the x's and the y's all canceled out. That is the reason why this ended up with no solution. Similarly to substitution, if you had ended up right here, instead of 0 equals negative 22, you ended up with 0 equals 0, that is, everything canceled out. This would be an example of infinite solutions. You can have a number equals another number, but since the way elimination works is it's going to cancel everything on the left side, infinite solution is virtually always 0 equals 0 on an elimination problem.